you've seen any of the videos on my channel before, you know I actually despise tips. Like in the way that other people actually talk about tips for the SAT, they're always so general and unspecific. They're always like, oh, just plug in numbers for the graphs and figure it out. Just use process of elimination. Eliminate similar answer choices. Use the similar answer choices to try to find the right one. It's always going to work. These tips are like somewhat useful, right? But it's only if you're trying to like cheat your way to a higher score. And the reason why I say cheat is because you're not genuinely learning what they want to test you, and it's not going to work 100% of the time. That is the lie that is sold by these tips. But there are tips that could genuinely help you, right? And if you want to actually improve your score, work on genuinely increasing your score through learning the methods that you need to learn. I have a bunch of other videos on that, but this video is for things that you could instantly learn just by me telling you them, and they're pretty simple to memorize or go find on the internet and memorize, and you'll instantly boost your score as a result of knowing them. So hi, I'm Karthik. These are 4 tips that are going to instantly boost your SAT math score. All right, so the first thing I'm going to talk about is formula shortcuts. So in the SAT, especially with all the algebraic questions, we get these problems that are like, they give us some algebraic expression, and instead of asking us to solve for x, they ask us to solve for 5x, x plus 5. They ask us to solve for the variable and some additional term as well, right? And there's a trick with almost always there's a trick with these kind of questions where they don't actually want you to solve for the variable, right? And that might seem so weird, right? But they don't want you to solve for x. They want you to solve for the expression, right? So here's a quick example that's going to demonstrate what I'm talking about, right? So you have this example that 2x plus 4 equals 100 and 6x plus 12, what does that equal, right? Well, you could solve for x here and plug it into the next equation and then figure out what it is. Or you could use this shortcut, which I don't have a specific name to call it, but it's almost just pattern recognition, right? If you notice 2x plus 4, right, and 6x plus 12, they have this common denominator of 6, right? They have this multiple where if I multiply the entirety of 2x plus 4 by 3, right, and I get 6x plus 12, as a result of multiplying 3 by 2x plus 4, you get 6x plus 12. Right? So basically what that means is I never have to solve for x. If I multiply one side by 3 and multiply the other side by 3, the equation is still the same. So 6x plus 12 is 300. And I could solve that in about 5 seconds just by knowing that they have a common multiple. It was my pattern recognition that allowed me to solve that. So always look, especially in algebra and any sort of questions that make you solve for something and put your answer in terms of a expression, not just a variable, just know that there's probably a formula shortcut that you could use. You could multiply by 3, divide by a certain number, factor out something to make it easy to solve. That's basically what they want you to do here. You need to apply this by learning about pattern recognition. Always try to have that pattern recognition in your head. And it's going to be very hard to find because even if you get the right answer, you might have just taken too much time. And there's no way of knowing if there was a pattern or there wasn't a pattern unless you just consult someone more experienced than you. So just focus on trying to find these, and they'll eventually show up and you'll get better at them as you try to do it more. Okay, so any equations that are just graphical, right? So every time you have equations on graphical equations, or anytime you have any problems that are about anything graph related, or like the formula for graphs, right, in all the different forms, here's a tip that you could use that's going to like help you solve all of these immensely. Instead of like memorizing like what the certain graph does and how it acts and what it generally looks like, just memorize the basic forms, right? So if that's like y equals mx plus b, know what m is, like know that's the slope, know b is the point of interception, right? So know about m, know about b, and know about the different forms you could put that in, like point slope form, you could put that in standard form. Know about all the different forms you can potentially put that graph in and what the graph on its own would look like. And this isn't specifically aligned to linear equations, but more like something like exponential graphs. For example, with exponential graphs, no matter what you have as the base exponential graph, right? I don't move it up or down, left or right. The exponential graph is going to look something like the point of that it's going to cross the y-intercept is always going to be at 1, right? Because if you take anything and give it to the power of 0, it's always going to equal 1. So that point is always going to exist unless it's moved up or down. So if it's not on that point, you know that the graph has been shifted up or shifted down. So memorizing these base forms, right? And also 1 comma b stands for 1 comma base. So if you put anything to the power of 1, it's just going to equal what that thing is. So 2 to the power of 1 is 2, 3 to the power of 1 is 3, right? So that's what base represents. That's also one of these points. So you need to try to figure out, what are these points? Are they really stretched out? So is there like a factor that the whole graph is multiplied by, or is it shrinked, right? Is it up or down, left or right from where it's supposed to be? And knowing these base forms and base graphs are going to help you solve every single graphical equation so much easier, right? For quadratics, memorize all the quadratic forms. That's all of, like, this is instantly going to help you solve 20% of the tests like that. You're going to be able to know how to solve them just by understanding these graphical equations and these, like, how they're normally interpreted and what the shifts do, what every variable means, right? It's not that difficult to memorize. It only takes about 1 day of just learning all of them, right? Now, formula changes. This is another version of that pattern recognition, but it's a little different in that you're not recognizing a pattern, but you're merely applying what the question tells you, right? So there's this question that I countered upon recently, and it was the volume of this sphere, right, is 20. And they give you the volume of a sphere equation on your formula sheet. And when the radius doubles, right, there's a new sphere and the radius doubles, what's the new volume? And so many people go to this idea of, okay, let's solve for the radius by dividing by all of these random things that aren't whole numbers and then taking the cube root of it. That's the wrong way to go about this question. Don't solve for volume or area when you get a percent change like this, like 50%, like double, like triple. Don't solve for the volume or area. There's a way that you can do this so much faster and so much easier, right? So understand that the volume formula is just like, the only thing that changes here is the radius, right? So everything else stays the same. The radius just goes from r, right? So what it is, to 2r, right? So if I were replacing r with 2r, I would put it in the parentheses and I'd cube the whole thing, right? Because the volume of a sphere formula, r is cubed. But now I'm cubing 2r. So it becomes 8r cubed instead of r cubed. So in the original equation, we just had r cubed. But in our new equation, we have 8r cubed. Now that means that our volume increased by a factor of 8 because the radius doubled, right? So I don't actually need to solve for the radius. I just need to know how it interacted with the whole equation, right? Because all I did is cubed it and it turns into 8. So the volume of the new sphere where the radius has doubled is just 20 times 8. It's literally that simple, right? You don't have to focus on doing any of these complex things and solving for things, right? The SAT wants you to waste your time. Don't let it. Use these things to save yourself time and put more time into those questions that are actually difficult and to actually take time, right? Okay, so circles, right? Know the formula, right? So circles is like a concept that's so strange because it's not just circles that you have to know about. You have to know about the circle formula. You have to know about, like, proportions. You have to know about completing the square, which is a concept that's, like, primarily, I would say, quadratics instead of actually, like, circles, right? So because circles are using all these external complex, like, things to make them happen, you need to know all of them, and then you can instantly understand circles, right? So knowing the formula, right? And it's just like the x minus h, and then that's squared, and the y minus k, right? Whichever variables that you use for those, and then it equals radius squared. That's the formula. And how do you turn things into that formula? You're going to get times where it's just going to give you something like x squared plus 8x plus y squared plus 5x or 5y equals 20, let's say. And that's just a completely random example. Don't try solving that. It's probably not a real circle. The thing that you have to do is complete the square. Now, it's very complicated what completing the square is, like, just conceptually, but basically it's just adding something to the equation so that I can factor the quadratic and add it to the end of the equation on the other side. So it still equals it, right? You can just look this up and learn this on Khan Academy in literally 10 minutes. But that'll help you turn things into the circle formula. Now, no proportions, right? Arc length and sector is just way more complicated than it has to be, right? If I'm looking at the arc length, right, of something, I just know it's a portion of the diameter. How do I figure out what that portion is? It's the whole entire degrees of a circle is 360 degrees, right? But if my like the highlighted portion of that circle is only 80 degrees, I know it's 80 over 360. That's the proportion. I just multiply it by either the circumference if it's arc length or area if it's sector. Remember that all of those things are just proportions of the total circle. Figure out what percentage it is in terms of degrees, divide it by the total degrees, and then multiply it out. So simply memorize all of these concepts and you're going to ace circles. Okay, here's some bonus things that you can just instantly memorize. So memorize what radians and angles are, right? Pi over 2 is 90 degrees. Memorize mean, median mode, standard deviation, like what it is and how something with a high or low standard deviation would react, and range, right? Just memorize them. That you can just look them up online now. Know SOHCAHTOA, right, which is just the sine, cosine, tangent, like parts of the right triangle. You just need to memorize those and know the complementary rules, right? That sine of an angle is equal to 90 minus that angle cosine, right? Just memorize those and know the quadratic formula and minus b over a, which is the sum of the roots of any quadratic equation if it's put in its standard form. All right, thank you guys so much, and I hope you learned something today.